Hello class, Kanush here. Today I'm going to show you how to transfer an AC to DC signal that's steady. So first of all, we start off with the transformer. Transformer is going to step down from 120 volts RMS to around 12 volt area, whereas you guys can see it's a lot smaller. It's not too much to deal with. And so pretty much we're going to do this first of all with the transformer. It's step down. It's going to step down 10. Alright, and then we're going to use a full bridge configuration. We're going to use that. We're going to use the 1N4001, and then this is going to step it down. This is full bridge, so there's going to be four of these diodes, and this is what the output's going to look like. It's still unfiltered, so this is when we're going to filter it with the choke input capacitor. The choke input capacitor is going to give us this output, and then over here, this is pretty close to what we're going to get for the output voltage on the last step. It's going to be around close to 12 volts. It's just under 0.5 volts under. So it's not over 12 volts. It's just close to this value right here. And I'll show you guys how we do this in the lab right now. Alright guys, we're in the lab. And so as you can see, 4 diodes. And this is connected up to the plus here. It's connected up to the full bridge. And then on the oscilloscope, our value is around 10 volts. That's not too bad. Now we're just going to have to filter this with a capacitor. This is where the capacitor comes in, and I'll show you how the capacitor choke input works. So now, when we take this probe here, we insert it on the capacitor end, and then take, as you can see, we have a ripple of close to 10%. This is too much ripple for us, so we're going to use this a technique that we learned here through class, which is a shunt regulator. So shunt regulator here, we can use a Z diode. This is an LED as an indicator. So now this is filter, the choke input, and this is our complete outputs. When we connect it on the oscilloscope, we can see our RMS value. Yes, on the oscilloscope it says close to 11.5, and that's not too much. It's just 0.5, close to 12 volts, and the DMM says it's around 11.46 volts, or close to 11.5, but on the oscilloscope, when we take these out, I should say our current value is extremely small, which is surprising also. When we connect it on the resistor here, you can see that the output currents is shown. So just across, here we go, and milliamps DC, that's close to 8 milliamps. That's pretty small for our case, and we have successfully converted an AC 120 volts RMS to close to 12 volts and pretty low milliamps. That's pretty big deal for us. This is a brand new achievement in history, and thank you for watching.